Okay, now today we're going to be dealing with day 3 and day 4. We're going to go from mixed to entire radicals and entire radicals to mixed. Now, even the title, a mixed would look like this: A root B, a number on the outside, and then something in the inside. An entire radical would just be like root C. And I'm going to show you how to make mixed radicals, and I'm going to show you how to make entire radicals right from. Also, the rule of radicals, that when I actually like it the other way, root A times root B is the same thing as root A times B. But a better rule that I even like is this one. If I had A root B times C root D, what would be the answer to this? Okay, putting up your hand, who could tell me the answer to this? No. No one? All right, who'd you get? It would be AC root BD. Now, here's the fun part. Can anybody tell me what the rule is in words then, in English? We say, let's bring it down to where we can all understand it. If you had to explain, now, if you ever have like a younger sibling, you understand what it means to get it so there it's understandable, right? Now, if I had to explain this to my 6-year-old or my 8-year-old, right, I could do it to give them a way to just keep going with them. Now, how would you explain this one to like an 8, 10-year-old? That's what I need. Anybody can make math complicated. What's the rule? Like in English, what's happening here? Because this is so compact. This is like, students right now are going, I have no idea what's happening there. Maybe some do know what's happening there. Okay? Who can help us out? Yep. Okay, so again, I'm with you. Just a bit too complicated. Can we even make it more simple than that? Yes? Okay, but what's going on outside the house? That's what I use. I'm a house guy too. What's going on outside the house? Okay. Not when they're multiplying, but still, give me an entire explanation of that you'd give to. You want to try it? Actually, AC isn't combining like terms. How did I get AC? What process? Multiplication. So when you multiply stuff on the outside, where does it stay? And multiply stuff by the inside? Okay, now that's what you have to be able to say. The stuff on the outside multiplies and stays outside. The stuff on the inside multiplies and stays inside until the next step. Because maybe I can get B out. You know how I can get B out? If B is a perfect square. I could get D out if it was a perfect square. And we're going to talk about all that. Okay? So here's 2 examples of it's called an entire radical. That is a mixed radical. Okay, so a mixed radical or an entire radical, everything is in the house. Okay, if our definition is more complicated than the word itself, then we need a better definition, right? So if everything's in the house, that's an entire radical. What should I call that thing that's outside the house? It actually has a name. No. Don't bring your stuff here. Okay. It is called a coefficient. Okay. So mixed radical has a coefficient. maybe if it's the stalker in your little world, that's fine. You know, as long as you're getting your math right, I'm like happy. I don't care. Okay? Now, all of these, let's make them entire radicals. Because right now they're mixed. So we're going to make all of these entire radicals. Now, when you make something into a different form, it can't change it, or else you messed up, right? So 5 root 7, whatever I'm getting, better equal 5 root 7, okay? Now you see how 5 is outside the house. 5 can get inside the house, but it turns into something when it gets in there. So if you bring the 5 in, it would look like this. You need to square it to get it in, okay? It's just like if you had, no, I won't go, okay? So now 25 times 7 is root 175. So go through those 2 steps. I've been teaching and doing these for a long time. I do the 2 steps, okay? There's accountability on me too. I mean, you guys may think, oh, you guys huge accountability, you're writing tests. Me huge accountability because you're writing my tests, right? Like, however you're doing is a reflection on how I'm doing. So I'm making sure, okay, I'm not getting them wrong either. Now, how about B? What would 1/2 be if it comes inside the house? 1/4, right? 1/2 times 1/2 is 1/4. Let's not be afraid of fractions. People are afraid of fractions. It's true. Okay, now, see what I did there? That would be root 10 over 4, because I multiplied the numerators, multiplied the denominators, which would be root 5 over 2. Now, how do you know you got that right for sure? Put your question in, hit enter in the calculator. Put your answer in, hit enter. And if you get the same decimal, you know you got it. Let's not do C, let's do D. What would 2 become when it comes inside the house? 8. Yeah, 2 times 2 times 2, because it is a cube root. And the 5 is there. So this would be cube root 40. Okay, so converting to entire radicals are really, so you know what, you need to do something like this too, right? Put an arrow, cube root, because you get in a square it, and then if you don't see the cube root, you're going to do square root again, then square root again, right? Let's go to the next page. Now, if you had to order radicals without a calculator, the trick is convert all to entire radical. Okay, that's the trick. And to order radicals with a calculator, that's kind of the no-brainer, right? Put them in to find decimals. I mean, we're all good with decimals, right? The hard part is when you get something like a, there's a 5, there's a 4 root 2, there's a 2 root 6, there's a 3 root 3. Without your calculators, and if you look at B, without your calculators, many of you would not know even what those numbers are. Okay? But how about if you don't know the answers, but you still know which one is the biggest and which one is the littlest? Okay? That's the trick we're going to do here. So, why don't we do, yeah, let's just do A. Now, let's make everything entire radicals. Like, how do you make 5 a radical? Square root, what? 25. Okay? What happens with 4 root 2? When it comes in the house, it will become 16 times 2. So this is going to be root 32. Now, do you see how it's really easy to compare root 25 and root 32? The next one, 2 root 6. 2's coming in the house to become 4, right? 4 times 6, 24. Okay, so this would be root 4 times 6. This one would be root 9 times 3, which is root 27. Now, it is just like you knew how to do in grade like 2. Just ignore. You can actually ignore the square root signs. It's like the smallest number. What is the smallest number? No. What is that really, though? 2 root 6 is the smallest number, isn't it? See? These are all the same thing. What would be next? 5. Next, 3 root 3 and 4 root 2. All done because all you do is you look at these. And root 25 is bigger than root 24. It should make sense, right? Not a lot, but it is bigger. Okay, now arrange them with your calculator. Okay, that's just too easy. Okay, does everyone know how to put cube roots in their calculator? So let's get the answer to this one. 2, so you're going to put 2. What's going to go next? 4. Okay, so math 4. And then you'll put 5. You should get 3.1, or sorry, 3.41995. Okay, so I'm not going to go through anymore, but you guys, the biggest number, it's the biggest number. Okay? You can write that down. Okay. Next. Day 4. Now these are the fun ones. It's when my grade 11s are writing their unit exam on radicals today. A little bit more challenging than these, but they need to know this. And some are weak on this part. Now, a mixed radical, by definition, everything has to get out of the house that can get out of the house. Okay? You can't leave anything in there that you can get out. So, the way you always have to do these, and this is why you need to get good at your perfect squares. Now, can we just list our perfect squares? They are 1. No, 4 first, right? 9, 54. Aren't we a little... I know, bit of a jump. Yep. Come on, after 9? 25. Okay, let's stop there. How about my cubes? 1, 8, 27, 64. Nice. Oh, that's pretty good though. The rest of the class, like, they were gone at 1, so you're doing good. Okay, so there's a bit of a help. Now, is there one of those numbers in 45? Now we're doing squares, so we are looking at the first column. So I'm looking for 2 numbers that add to 45. One of them is in that list. If they're not in that list, I cannot go any farther. I can't get anything out of the house. What's there, Matt? 9. So then I'm going to rewrite it like this. And please, can you do this too? 9 times 5. Now I deliberately write the 9 first, because it's my perfect square. Now, I'm getting 9 out of the house. If I kick 9 out of the house, it becomes 3. Why? Because I'm taking the square root of 9 to get it out. Okay? So this will become 3 root 5. So you kick the 9 out, and it becomes 3 in front. Because square root of 9 is 3. So 3 root 5 is the same thing as 45. Root 45. Okay, we'll do a few more. Now, the trick is to always write two numbers that multiply by each other. One of them is in that list in the red now. Okay? Okay? Now, what two numbers? Okay, I know you know. Just let's think about it. What two numbers multiply to 75? The first one is in that list. Times 25 times 3. So I'm just going to write that down. See, root 75 and 25 times 3, they are the same thing. Now, if I take the root of 25, what is it? So I get 5 root 3. Okay? A nice number in 18. Yes? Yes, but it's staying. Because I can't take the square root of 3. I can't get it out of the house. If I cannot find any perfect squares, then I like there's one in the book that it's like square root, what is it? It's like square root 15. Well, what times what equals 15, and one of them is a perfect square? Yeah, at least you take out a 1, you're not accomplishing anything, right? So this is the best you can do. You can't get anybody out of the house. But root 18, what times it? 9 times 2. The 9 comes out to become a 3. Okay, 80 is an excellent example of where students really struggle because they're like, how come mine's not right and theirs is right? Okay, I did it all right. I did it exactly like you told me to do it. Okay, square root 80. Give me two things. What times what? 4 times 20. Right? The 4 comes out, and that's 2 root 20. Okay, is there another way that I could write this so it's two perfect squares? Oh, sorry, a perfect square times any number. What's a bigger perfect square? Okay, you guys should be trying. There isn't 60 of them. There's like 10. 9 doesn't go into 80. 16 does, yeah. So this is 16 times what? Times 5. The 16 comes out and becomes a... So this is 4 root 5. So I have two answers. 2 root 20 or 4 root 5. Which one is wrong? Right. Yes, you're right. It is wrong. Why? You didn't get everybody out of the house. There's still another perfect square in 20. But it doesn't mean you have to sabotage it. In fact, when you're new at these and you see 4, you're going to bring it out. You may see I didn't take out as much as possible. That's okay. You can still keep going. Because 2 root 20, what is a nice... What times what? Equals 20. 4 times 5, right? Now the 4 comes out to become a 2. What's 2 times 2? And then you do get the right answer. Okay, so maybe you're going to take a couple steps. No big deal. Students panic. They're like, I'm not getting what do you need another step? You haven't got everything out. Okay, so you have to make sure. E. $49, good. So this would be 49 times 2. Now these are very contrived, you guys. I don't know if you know what that means, but it's like, it's just yelling out what the perfect square is. So you're going to see 98's a lot. You're going to see 200. That's just 100 times 2. There's always going to be a nice perfect square in there. So 98 you're going to get used to, right? Especially those 7 ones. The 2 ones you can do, but the 7 ones you're going to kind of have to almost recognize. Okay? So the 49 comes out to become 7 root 2. Okay, so root 98, entire radical 7 root 2 is the simplified. This is the most, what we call simplified, when you get as much out of the house as possible. Okay, now let's do a cube root. What's a nice cube root in 32? 8. So cube root 8 times 4. Do you notice I always do this step? I don't do this in my head. I find people like to do it in their head because it's faster, right? But often, it's faster getting to the wrong answer, which really goes against what you were trying to do in the first place, because now you've wasted time and you get no marks for it. Okay? That's got to be the biggest waste of time possible. So maybe take a little bit more time and get it right, and then you're not wasting your time. Now, what happens to the 8? Cube root of 8 is what? 2. So this would be 2 cube root 4. Why can't I take that 4 out? Because there's not a perfect cube. It's a perfect square, and we're so used to seeing that perfect square, we want to get it out, but we can't. It has to stay in there. Okay. Now, let's do H. Variables. Ooh, scary little variables. Now, the trick to do this is write it in forms of perfect squares. So 20 is what? The best I can. Like a perfect square times a number. 20. 4 times 5. See, that's still 20. I haven't changed it. Now, then we have an a squared, and then we have a b to the 4. Now, since we're squaring, make it b to the 2 times b to the 2, because that is b to the 4. Now, why did I do that? I'll show you in a second. What happens with the 4? It comes out to become a 2. It's gone. What does a squared come out? If you take the square root of a squared, what do you get? See, now you know why I'm going to put them in 2's. And the b squared comes out to become a b, and the other is a b. So there should be just a 5 inside. Now, it's not totally right, because what is that b times b outside? So the final answer would be 2ab squared root 5. Okay. Now, score at 50, a squared, b squared. 25 times 2, a squared, b squared. The 25 comes out to be 5. Can I take anything else out? A squared becomes a, and b squared becomes b. And what's left inside? 2. And that's simplified. Now, you're just doing them watching me, okay, and writing them down. So you won't get these until you practice them. My top students, which are all you guys, I guess, they asked lots of questions last period, right? But just little mistakes. And how come you can't do this? And I thought you could do this, okay? All those things, that just start affirming those rules. And until you start participating in this stuff, you'll never get it. Totally. Like, honestly, if you just watched me and then you went home tonight, forget it all. Okay? You do have to. Okay. Now, to fully simplify the radical is get everything out of the house. Legally. Okay? You can only take square roots or cube roots to get things out of the house. What's wrong? Yeah, you're all good? Okay, now, what if there's already stuff out of the house? Okay, so when I bring new stuff out, what do I do to the stuff that's already out? Multiply. Okay, so we have 4 root, and I rewrite the 20. Yes, I know. I take the time to do this, and I hope you guys do too. What times what? 4. Always do the radical first. Get in a good habit. Get in a good habit of getting, because that's right by the door, right? It's getting ready to jump. When it jumps, it becomes a 2. So what's out? So I do this. Watch this. I put a 2, and 2 times 4 is 8 root 5. So really, if you're ever going to get good at math, it's about habits, right? It's about learning a way to do it and do it the same way every single time. Okay? Because if you keep doing something every single, that's the only way you're going to master it. Unfortunately, if you do something different every other time, you don't really master it. Yes. In definition, simplest means you've actually square rooted everything possible. Because there's a square root sign saying, get this square rooted. If you leave the stuff in there that can be square rooted, it's not simplified. I don't get what you mean. Oh, because that's a decimal, and that is approximate. Okay, that's a long decimal, right? It's just kind of like, 4/7. That's exact, and the decimal that goes on forever, that's not exact. Okay? Now, 3 root 50. 3, and I go like this. What times what? 25 times 2. 5 comes out. 25 comes out to be. So 5. So take the time. You can do this. 5. 5 times 3 is 15 root 2. 5 times 12 is 4 times 3. What's wrong? B or C? 25 came out. 3 double 5. There's a 3 up there already. 3 times 5 is 15. Okay. The 4 is coming out to become a 2. 2 times 5, 10 root 3. Okay. Cube root. Again, you just get, these are like so contrived all the time. What cube root nice it goes into 54? 27. So this is 2 cube root 27 times 2. Now be careful. Thank you. One of the worst habits, me included, is when I rewrite this, I forget to put the 3 there. Okay, remember that 3 means cube root, right? I always forget it. So when you just corrected me on that one, I put like 2 3s. I was so paranoid. Because last class I lost it. It's like gone, fell on the ground somewhere. So I was like, oh, I'm putting it in this time. I'm going to show them how smart I am. I screwed it up. Okay, 27 comes out to become a... Ooh. No, oh, not 9. Cube not divided by 3. Cube root of 27 is 3. So that's coming out to become a 3. 3 times 2 is 6 cube root 2. Okay, so there is lots of time for you to practice. You might want to start on the worksheet. Okay, so we're doing both homeworks. I've given you a brown worksheet. If you haven't got one, there's a pile up here. Just